Okay, guys, just want to talk about some of the internal components of an alternator. Here we have the part that goes round, rotors go around, and the stator. The stator stays still. This is really where the magic happens inside the alternator. So just checking the rotor here. The way this is built up is this this side of the poles are all connected together. So these guys, this guy and this guy, same component. This guy and this guy are the same component as well, but they're separate from each other. And we can bring in some trusty little testing tools here. Got the meter set to resistance. Again, you want to touch them together, make sure that the meter is working correctly. We'll have what's that, 0.3, 0.4 ohms resistance just within the wires that I'm using and the connectors. Nothing wrong with that. We get an understanding. So if I touch this pole, I guess I'll go over here, touch this pole and touch this pole, you see that they're connected together, right? Very, very low resistance between the two. If I touch these two, again, you see that they're connected together, same component. But they're connected through the shaft. So this becomes essentially a magnet. So these guys are connected around here through the shaft and connected to this side, just like a magnet would be. So you'd have a north pole and a south pole. And the way that it would work is you'd have a north pole and a south pole, and then these poles are extended over top of that coil of wire. Inside of there is just a great big coil of wire that wraps around the core around the rotor here. And each of those ends, as you see right there, one end, and right there, one end, each of those are going to be connected to one of the slip rings. So there's our two slip rings there. When current, so I'll show you, we can test. Oh, would you look at that? It's probably why it's on our bench. They're supposed to be connected, those two, through the coil of wire. So somewhere this guy's got an open. Kind of want to find it now, but I won't waste our time. Either way, we should get a reading of continuity throughout that coil of wire. Oh. Don't know. Anyways, I should stop. Okay. So what happens is when current is applied through these slip rings, it gets applied through one, goes through that great big coil of wire, and then grounded through the other side. When current is flowing through that coil of wire wrapped around a core will create a magnetic field. So in essence, this core becomes magnetized in the rotor. So this really becomes a magnet, and the strength of the magnet is dependent on how much current goes through these slip rings here. And that's going to be referred to as field current. So how much current goes through there creates a size of magnetic field going in the rotor. The strength of this magnetic field will get induced into the stator. Now again, from what you know in stators and books, this guy has 3 connectors, each of them with 2 wires going to it. So that means this is a delta wound stator. And remember, the properties of delta wound stators are it has a good high output at high speeds, but it doesn't have as good of output at low speeds. Most alternators these days are delta wound stators. And again, it's got a laminated core around it for 2 reasons. One, to hold it in place and keep it from moving. And the second, magnetic fields are always induced better when you have cores of metal, not just coils of wire. And if we were to check any of these in the stator. Oh, there we go. You see, they're all going to be connected together, regardless which one you touch. All right, so those guys are all connected together. They're all part of one wire, but they're connected like a triangle. So one coil goes here, one coil goes there, one coil goes there. And so these are connected as a triangle, and these would, in essence, be the 3 points of your triangle with the coils of wire in between. Now the magnetic field from the rotor will now pass by these coils of wire, and if a magnetic field passes by a coil of wire, this is where it starts inducing a sine wave and creating that AC voltage. But AC voltage isn't much good for automotive use. So what they do is from these connectors here, they go through a rectifier to create DC voltage. And then that voltage is now usable to charge the battery and to run other items in and around the vehicle.